Okay, howdy IB. I want to work through this problem. They tell us, this is in the book, it says x squared plus 4 over x raised to the 12th power, and they want two different things. They want to find the coefficient of, I can't spell, of the x to the 6th, and then they want to find the constant term. So I figured out a better way to teach it after I made the videos a couple years ago. So let me see if this makes sense, or if this helps. So hopefully, I think you've seen some other examples. This is just kind of a follow-up if you need it. What happens here is that each term becomes, well, you've got a, it's going to be 12 choose something, and then you have this x squared to a power. And then the 4 over x is also going to be to the same power. Notice this and this are the same, typically. There we go. Sorry. Okay. So here's how we would set this up before. What we know is we know that the box plus the triangle have to equal 12 because this is it's raised to the 12th. So the exponents are going to be raised to the exponents added up together are going to equal 12. And then, so that has to happen no matter what. Well, then we know we've got this, if we look at my exponent, if our exponents, if we were to multiply, we're going to ignore this part for just a second because we don't know what that combination is, but we're going to have x to the 2 box times, well, 4 to the triangle over x to the triangle. Well, notice this is x to the 2 box. This is 4 times 4 to the triangle. This is getting a little confusing, but hang tight, hang with me. This becomes x to the negative triangle when I move it from the denominator to the numerator. Okay, so now I have the same, there's still something here, and I should write it down, but sorry. This becomes x to the 2 box minus triangle times, well, 4 to the triangle. Oh my goodness, okay, here's the point. What I notice, and I don't write all this out every time, what I notice is that when I look back at, hang on just a second. When I look back up here, I see that I have an x to the 2 box and then an x to the negative triangle. And this, they just told me on A that I want that coefficient, 2 box minus triangle to equal 6. Okay, so now here's my point. This is a little system. So now you're back in Algebra 1, and you have a box plus 2 box is 3 box, and a triangle minus a triangle, it's gone, and this adds up to 18, and so your box has to equal 6. Okay, so that tells me, sorry, let's get rid of that. That tells me that this box right here is 6, which means, well, the box in the triangle had up to 12. This is also 6, and this is also 6. Let's see, what would really happen? This is still a 6 choose 12, which I can do either with the formula or the calculator at some point. This becomes x to the 12th, and this becomes, well, 4 to the 6th. We'll grab a calculator for that. Anyway, yes, calculator. I mean, it's 64 squared or something. I don't know that off the top of my head. This becomes x to the 6th in the denominator. So I've got the numbers out in front that I'm going to have to deal with. But then my x value becomes, well, I have 12 on top and 6 on bottom, and so they clean up to give me that. So what I would need to do at this point is grab my calculator. Sorry, you can't see it. Hang on. Go calculator, math. I lied. Hang on. I haven't done it yet this year. Option. Go calculator. So on your Casio, you can go to option and then go over to probability, which you have to go over to get it. And then NCR, so it's going to be 12, choose 6. Is this term right here is 924. This term 4 raised to the 6th power. I don't know it off the top of my head, but it's 4096 times x to the 6th. If they say, what's the coefficient, I just need to take 924 and multiply it by 4096, and I get, oh my, 3784704, and yes, okay, so if they say, what's the coefficient, this part is the coefficient. Would I take off if you include the x to the 6? I don't know, probably not. Okay, let me see if I can do the constant term a little more clearly for you. It was x squared plus 4 over x to the 12. Okay, so what we know is we've got a combination We've got x squared is raised to this power, 4 over x is raised to that power. We know that the box plus the triangle has to add up to 12. We know that 2 box minus triangle, because this is now, I could move this to the top by making it a negative exponent, is going to equal, well, they said they want the constant term. Well, that's where the exponent is equal to 0. Okay, and so now I'm going to solve this system. I have 3 box is equal to 12. Therefore, box is equal to 4. So let's come back and put in a 4 here, which means that this has to be 8. Since they add up to 12, this is 8. So now it's 12 choose 8 times x to the 8th times 4 to the 8 over, that's 4 to the 8, that looks funny, sorry, my bad, over x to the 8. Notice the x's cancel out, and that's exactly what we wanted. Okay, so now I can come back and grab my calculator. Oh, I hit exit, I shouldn't have. I meant delete. You can't see it anyway. 12 choose, I think I have a video of me working with the calculator. 12 choose 8 is this. The x's are gone, and I have, let's see, oh, I don't know, what's 4 to the 8th is some big number. 65536, yes, I would give you a calculator. Multiply that number times 495, and oh goodness, 3244032, oh good Lord. Okay, but that hopefully is what the book said. Yep, it looks like it. That is the constant term. So the difference between what I have done in the past and what I'm doing this year or my previous videos is I kind of make you guess about how to find those exponents, but I think that this system, setting up a system using boxes and triangles, you put other variables if you want. I just like the boxes and triangles because then you can fill them in. Hopefully this helps. Good luck. Go practice.